So far, we have discussed IP addressing and subnet mask, then alien concepts. So now I would like to take you through a brief explanation about subnetting and alien algorithms and how does this work. So subnetting is the process of creating new networks by stealing bits from the host portion of a subnet mask. So there is one caveat: stealing bits from hosts creates more networks but fewer hosts per network. So the best example is when we were looking at classes of IP addresses. At that time, we have seen class A, class B, class C, class D, three, almost four classes. Out of which, if you see the default, each has the default default subnet mask. So if you see, as you move from class A to class C, as you move up from one subnet mask to other subnet mask, the number of octets that define the uh, network has been increased. So because of that, the number of per hosts per network will reduce. So consider the following class C network. So the class C network, as I have told you, it consists of total four octets, out of which three octets define the network and one octet uh, define the host. So the default subnet mask for this network is 255 dot 255 dot 255 dot 0. So this single network can be segmented or subnetted into multiple networks. For example, assume a minimum of 10 new networks are required. Resolving this is possible using the following magical formula, that is 2 power n. So the exponent n identifies the number of bits to steal from the host portion of the subnet mask. So the default class C mask, that is, it consists of the default class C mask. The subnet mask for the class C is 255 dot 255 dot 255 dot 0, which if we convert that into binary, it looks like this, absolutely looks like this: 255 all ones, 255 all ones, 255 all ones, 0 all zeros. So that's how it looks. Now there are a total of 24 bits set to 1 out of total 32 bits. 24 bits set to 1, which are used to identify the network. So there are a total of 8 bits set to 0, which are used to identify the host, and these host bits can be stolen. So stealing bits essentially involves changing host bits that was set to 0 in the subnet mask to network bits, that means setting to 1 or 0. So if you put it in a simple way, so you have total 24 ones and 8 zeros. What you can do is you can replace fewer bits from these zeros as 1. So this 0 can be converted as 1, so then automatically uh, that will be converted, that bit will be converted as a network. As a network, the bit will be converted as the bit which represents or defines the network. So remember, network bits in a subnet mask must always be contiguous. Skipping bits is not allowed. So consider the result. If 3 bits are stolen from this, so this 3 First three are stolen from this using the above formula. So 2 power n. So total we have stolen 3 bits. 2 cube, total 8 networks can be created. Absolutely correct. Absolutely correct. So however, a total of 8 networks does not meet the original requirement of at least 10 networks. So consider the result if 4 bits were stolen. If you steal 4 bits, 1, 2, 3, 4, then 2 power 4 equals to 16. 16 networks created, or 16 networks can be created. So a total of 16 new networks does meet the original requirement. So stealing 4 host bits results in the following new subnet mask. After stealing, okay, you have stolen these four bits. That means these 4 zeros has to be replaced with ones. So that's what, after stealing 4 host bits, so results in the new subnet mask. It exactly looks like this. So now we have one more rule to do the similar kind of calculation, that is 2 power n minus 2 rule and subnetted networks. So what is this? So in the previous example, a class C network was subnetted to create 16 new networks using a subnet mask of 255.255.255.240 or 240. So basically when you convert this into CIDR, it will become like the IP of that this thing, and then forward slash, this it will become a 28, because 8 plus 8 plus 8 plus 4, so 24 plus 4, 28. So 4 bits were stolen in the subnet mask, leaving only 4 bits for hosts. To determine the number of hosts, this results to determine the number of hosts, this results in, for each of new 16 networks, a slightly modified formula is required. For that, what we use is 2 power n minus 2. So let's do the calculation. 2 power n minus 2. So let's put how many, consider the result if 4 bits are available for the host. So 2 power n minus 2. So we have how many bits are available for host? Only 4. 1, 2, 3, 4. So 2 power 4 minus 2. So 16 minus 2. So 14 usable hosts per network. We use 2 power n, basically 2 power n, to get the networks, how many new networks can be created, and 2 power n minus 2 to get the how many usable hosts can be created per network. So thus, a subsetting a class C network with a forward slash 28, that CIDR forward slash 28 mask, in spite of saying 255.255.255.240, you can simply put it as forward slash 28 mask. So creates a 16 new networks with the 14 usable hosts per network. So but before we conclude this calculations, so why uh, why 2 power n minus 2 rule is used? Why is the formula for calculating usable hosts is 2 power n minus 2? Why not just 2 power n plus 2 or something? Because it is never possible to assign a host an address with all zeros or all one bits in the host portion of the address. So these are reserved for the subnet and broadcast addresses. We have seen in our previous slide about the broadcast address. If all are ones, then we call it as a broadcast address or subnet address. So broadcast or subnet address, so zeros and ones will be reserved for those purpose. So that is the reason always you minus 2 hosts from the formula. So thus every time, so 0 is for subnet if all are zeros, that represents a subnet. if all are ones, that represents a broadcast address. So that's the reason every time a network is subnetted, usable host addresses are lost. So that's the reason our formula to calculate the number of usable hosts per network is 2 power n minus 2, whereas number of new networks that can be created is 2 power n. I hope you got it clear. You got it everything. And if you have any doubt, just ping me on comment section.